Hi guys, this is the video for chapter 2, lesson 8. This is the last lesson of chapter 2. So after this, I think your next class will be a review day, and then that following class, which should be a Friday, will be your chapter 2 test. On your chapter 2 test, you can use any handwritten notes. You can use the properties and definitions page that we have taken notes over. And you can also use the postulates page that we took notes over that basically goes over like 2.1, 2.2 postulates that goes all the way down to 2.7, and it describes characteristics of points, lines, and planes. So you can use those 3 things on your test. You cannot use your study guides. And you cannot use your homework or anything, but you can use your handwritten notes that were taken in class, and you can use the 2 handouts that I gave you that we filled out, okay? So today we are actually gonna add on to this page. So if you have that, get that out. And this is like gold for this lesson, for this class, for this chapter, really, this is like gold right here, because you want to add on everything you've learned to this and accumulate all that, and this will be very helpful for you when you do your proofs. So I want us to add on here the segment addition postulate, because this postulate is what we learned in lesson 7, but we didn't add it on here. And let's review a little bit what this is about. So this one was really talking about how if you have 2 parts of a segment, they add up to become the entire part. So if I have A, B, and C here, I've got this segment AB and then this segment BC. I can add those up and that equals the entire segment. So AB plus BC equals AC. And I recommended that you wrote out your segments where the middle point, the center point is in the middle here, so that you can see that B is kind of that point that joins the 2 segments together, and then the entire part is AC. Now, we're gonna take a look at a postulate that says something very similar to this, but is just a different thing. So the angle addition postulate. Very similar, same kind of name, but except we're looking at angles. So what do you think this postulate is talking about? So let's draw a picture here. I've got an angle A, B, C, and then there's a ray that's in the middle, and it's BD right here, okay? So what this is saying is if I have 2 adjacent angles and they share a ray, then the 2 angles added to each other equals the entire bigger angle. So angle ABD plus angle DBC will equal angle ABC. So the picture really helps us visualize what's going on. I've got 2 adjacent angles. They share a ray, and these 2 angles aren't total. They might not be the same size, but we know that together it makes the bigger angle. So that's what we call the angle addition postulate. So we're gonna add on to this page, and we might have to use the back of it. So maybe on the back you can also make a T-chart similar to what's on the front, and we will add on to it. So we're gonna learn something called theorems, and theorems are really just, they're like postulates, except for theorems aren't as straightforward. So they're truthful things that have come out as statements because it's been proven. So it's not like a fact when you read it right away. You don't see that it's just a factual thing. But in a layer of events, it can be proven to be true. So um, we're going to be able to use some of these theorems also in our proofs. So instead of proving the theorems, we're going to use the theorems to help us make further conclusions. So up here where it says some supplementary angles and complementary angles, I want you to cross this off and write supplement theorem and complement theorem. Okay, so there's two theorems now related to supplementary and complementary angles. So the supplement theorem, I'm going to write out the definition. You can write this down. Then I'll describe it with a picture. If two angles form a linear pair, then they are supplementary angles. Now, this might be kind of a duh statement, right? Because you're reading this, you're like, well, I know that. So I probably don't need to totally draw it out, but here I'm going to make that font smaller so I have room to draw. But if I have two angles that are a linear pair, so linear pair means two angles that form a line, meaning there's the line right there, angle 1 and angle 2. So let's say they form a linear pair. Then what this is saying is if angle 1 and angle 2 are a linear pair, so if angle 1 and angle 2, my pen isn't very good here, then angle 1 plus angle 2 are supplementary angles. Now, how many degrees are supplementary angles again? They're 180. So I can say then they add up to be 180 degrees. Got it? So let's take a look at complement theorems. So for a complement theorem, this has a little more going on. So if if the non-common sides of two adjacent angles form a right angle, then the angles are complementary angles. Okay, so let's kind of show what's going on. So what does it mean, non-common sides of two adjacent angles? What is that saying? What that is saying is if I have two angles here, the sides of the angles that they don't have in common, so these outside sides, form a right angle, then these two angles are complementary. So what we would say, let's say that this is A, B, C, and D. If AB is perpendicular to BD, then I could say that angle 1 and angle 2 are 90 degrees. They're complementary. So the non-common sides, meaning the sides that, they don't share, they form a right angle, then those two angles, if they're adjacent, meaning they're side by side, they add up to be 90 degrees. Okay, so let's take a look at your study guide. On your study guide, we're going to use these theorems to help us conclude missing measures, okay, to find the missing measures. So the theorems and the postulates are up here, but I want us to write them down and also just process what's going on, and then of course use them as part of your notes that you can have accessible. Up here, we didn't talk about this one. It's the protractor postulate. That's kind of like the ruler postulate, which is really just saying that any angle can be measured using a protractor. But we can measure our angles, but when we're doing proofs, we don't need to measure them because that's not usually the goal of our proof, is to find the measurement. The goal is to find characteristics that we see. So just know that you can use a protractor to measure your angles, and you can find an exact measurement, but we're not normally going to use this postulate. Okay, so down here, we're going to take a look at 1, 2, and 3. It says find the measure of each numbered angle. So read the directions carefully because it's saying I need to find the measurement of my angles. And it says, and name the theorem that justifies your work. So how do I conclude the measurements that I find? What's the theorem that I'm using? So really what that's saying is, are you using the supplement theorem or are you using the complement theorem to work these problems out? So let's look at number 1. This is saying that angle 7 equals 5x plus 5. So here's 5x plus 5. And then angle 8 equals x minus 5. So what's the relationship between angle 7 and angle 8? Do they form a straight line here? They do. So if they form a line, then we can conclude that 7 and 8 are linear pairs. If 7 and 8 are linear pairs, what can we conclude? They would be supplementary angles, right? So these two angles add up to be 180 degrees. So what I see here is that angle 7 plus angle 8 should equal 180 degrees. And the reason I know this is because of the supplement theorem. So I'm going to write them justifying my reason, supplement theorem. And now we have to work it out because we actually have to find the measurement for each angle. So what I'm going to do is I'm going to replace angle 7 with 5x plus 5, because 5x plus 5 is basically what the equivalent, the measurement for angle 7. And I'm going to replace x minus 5 with angle 8. So I know angle 7 plus angle 8 equals 180, which means 5x plus 5 plus x minus 5 equals 180. I'm subbing in the algebraic expression for each angle and working that out. So now I've come up with an algebraic equation. I can work it out. 5x plus x is 6x. Positive 5 plus negative 5, or 5 minus 5 is 0. So all I have is 6x equals 180. Divide by 6 on both sides, and x equals 30. Am I done here? No, because they didn't ask me just to find x. They asked me to find each angle. So I now have to sub 30 back into each expression and work out the problem. I think I'm going to have to switch gears here and use the whiteboard. You might want to do this on a piece of paper. So numbers 1, 2, and 3, you might not have room to do on your study guide there. So x equals 30. I now need to plug that in to angle 7, plug that into the expression for angle 8. So now angle 7 is 5x plus 5, which means I'm going to do 5 times 30 plus 5. Angle 8 is x minus 5. So I'm going to replace x with 30 since I found that and work that out. So 5 times 30 plus 5, when I work all this out, equals 155. Because 5 times 30 is 150. 150 plus 5 is 155 degrees. So put that little angle measure and that one's done. So I'm going to circle my answer. And then angle 8 equals 25 degrees. Put my degree sign to show that's degrees, and that's my answer. If you wanted to check your answer, I know that angle 7 plus angle 8 equals 180. That's one of the characteristics. So if I sub in 155 plus 25, I should get 180. When I add that up, that equals 180. Good. So I have got the correct answer there. All right. Next. Next problem. Problem number 2. So I'll take a look at it and then we'll switch to the whiteboard to work it out. Okay. So here it says angle 5 is 5x, angle 6 is 4x plus 6, angle 7 is 10x, and let's see, 12x minus 12 is angle 8. So what do I notice about all these angles? All of them together form a straight line right here. Anytime you see a straight line, you can think whatever is over here that makes this line, that's 180 degrees, right? A straight line is 180 degrees, or a half circle is 180 degrees. So all this together should be 180 degrees, which means if I add them all up, angle 5 plus angle 6 plus angle 7 plus angle 8 equals 180 degrees. What tells me that angles added together forming a linear pair equals means that they're supplementary? That's called the supplement theorem, right? So that's the supplement. I'm using the supplement theorem to help me work this out. This is supporting my reasoning for when I work these problems out. So I'm going to switch over to the whiteboard, and you're switching over to your notebook paper, hopefully. And angle 5, so I could say angle 5 plus angle 6 plus angle 7 plus angle 8 equals 180 degrees. Now I'm going to replace each angle with the expression given to it, meaning 5x for angle 5 plus 4x plus 6 plus 10x plus 12x minus 12 equals 180. Now let's look here. I've got my x, my ones with my variable. So I'm going to add those all up. 5 plus 4 plus 10 plus 12. 19 plus 12. And what does that x equal? 186 divided by 31 is 6. X equals 6. Okay, so are we done here? We're not all the way done, because think about each angle. Angle 5, angle 6, angle 7, angle 8. We have to find all of them. So angle 5 is 5x, which means we can do 5 times 6, and that's 30 degrees. So angle 5 is 30 degrees. Angle 6 is 4x plus 6, so 4 times 6 plus 6, which is 30 degrees too. And then angle 7 is 10 times x, which means 10 times 6, that's 60 degrees. And then angle 8 is 12x minus 12. So 12 times 6 minus 12 is also 60 degrees here. So if we add all these up, check yourself to see if it adds up to be 180. If I add these all up, that should be 180 degrees. And that's a good sign that I've done them correctly. All right, problem 3. So next problem here. we've got another figure here of different angles, and it's saying they form a line right here. And the information given to us is actually 11 and 13, angle 11 and 13. So that's the one we want to find. So if we look at 11 and 13, they also form a line, which means if they form a line, they're supplementary angles. And so we are using the supplement theorem to help us conclude how to work this problem out. And so switching gears here to our paper, we are going to take a look at what we have. So I know that angle 11 plus angle 13 equals 180 degrees. That's from the supplement theorem, is telling me that when I add these two up, that form a line equals 180 degrees. So let me replace what their little expressions that describe that are. So angle 11 is 11x, and then angle 13 is 10x plus 12. So if I add these two together, that should equal 180. And so let's combine our x's. 11 plus 10x is 21x, and plus 12. Now we're going to subtract 12 on both sides. And so 21x equals 168. 168 divided by 21 is 8. So x equals 8. We're not done here because we need to find each angle measurement. So 11, angle 11 was 11x, which means 11 times 8. So angle 11 is 88 degrees. Okay, angle 13. Angle 13 was 10x plus 12. So when we add all that up and multiply 10 times 8 is 80. 80 plus 12 is 92. Angle 13 is 92 degrees. Now, there's another angle on your picture. Did you notice angle 12? We need to find that one too, because that's one of the numbered angles. So if angle 13 is 92 degrees and angle 12 is supplementary to that, then wouldn't that just be 180 minus 92? Or in other words, 88 degrees. So you can even notice that, let me show you our picture here. If you found one angle, like this angle is 88 degrees, this angle is 92 degrees, and because they're supplementary to the same angle, this angle should also be 88 degrees, right? Because these two added up should be 180, and these two added up should be 180. So that's another interesting characteristic that I see. Anyway, so work those out, and you have those in your notebook. Let's take a look at this next page. So we've got a few more theorems to add to our chart, and then some other characteristics that we see about angles and their characteristics here. So let's flip to the back probably of your properties and definitions page, and we're going to add on to that. So the first one that we're going to look at is congruent supplements theorem. And then the next one we're going to look at is called congruent complements theorem. And we'll take a look at what these are here. So these two theorems basically describe what we just looked at in that last problem on number 3. Let's write out what it's saying, and then we'll talk about it. So this is saying angles supplement to the same angle or congruent angles are congruent. What is that even saying, right? Let's write this next definition down. Angles complement to the same angle or congruent, or two congruent angles. That's why it didn't make sense. Or two congruent angles are congruent. So let's draw a picture of what this is saying. Okay. If I've got a line and I've got angle 1 and angle 2. Angle 1 and angle 2 are supplementary, okay? They add up to be 180 degrees. And then I've got angle 1 and angle 3. They are supplementary. They add up to be 180 degrees. So I have angle 2 and angle 3 are supplement to the same angle. Therefore, angle 2 is equal or congruent to angle 3. So my picture is not the greatest. Maybe you can draw a better one. But what this is saying is angles supplement to the same angle are congruent, or two congruent angles are congruent. So if they are supplement to the same angle, then these two angles will be congruent. So let's talk about what that would look like for our complementary angles, okay? So I've got angles 1, 2, and 3. So if angle, let's see, if angle 2 and 3 form a complementary angle, and then angles 1 and 2 are complementary, then angle 1 is congruent to angle 3. So they're both, angle 1 and angle 3 are complementary to the same angle. Therefore, angle 1 and angle 3 are the same. All right, let's add on to our list. I'm going to use this feature right here. So I'm going to make a chart just like you guys are. A little chart here. And we're going to add on to this. So the next theorem that we're looking at is called the vertical angles theorem. And what this is saying is that if I have two vertical angles, it's really just the definition of vertical angles, but if I have two vertical angles, then they are congruent. So angle 1 is congruent to angle 2. So this theorem basically just describes that two angles that are vertical are congruent, okay? Then we have these theorems that are labeled by their 2.9, 2.10, 2 point whatever, keep going. So I want to take a look at the study guide with you here because I'm not going to write these out. You won't probably use these theorems in your proofs, but let's just take a look at them to understand these characteristics. So theorem 2.9 basically just says perpendicular lines intersect to form 4 right angles. So it's just saying that when you have two lines that intersect and they're perpendicular, then there are 4 right angles. Angle 1, angle 2, angle 3, angle 4, all of them are right angles. Okay. Theorem 2.10 says all right angles are congruent. So because they're all 90 degrees, they all have to be congruent. Okay. 2.11 says perpendicular lines form congruent adjacent angles. So if I have two perpendicular lines, they form congruent adjacent angles, meaning angle 1 and angle 2 are adjacent, they're side by side, and they're both the same measure, which is 90 degrees, right? 2.12 says, if two angles are congruent and supplementary, then each angle is a right angle. So if two angles are supplementary, meaning they add up to be 180 degrees, and they're also congruent, they're also equal, if angle 1 equals angle 2, and they add up to be 180 degrees, they have to be supplementary, and they have to be right angles, right? They have to be right angles here. 2.13 says if two congruent angles form a linear pair, then they are right angles. So if two angles make a line, then they are congruent. So it's kind of saying the same thing as 2.12, but it's saying if they're a linear pair and they are congruent, then they are right angles also. So all those theorems have to do with right angles and what they are. Let's take a look at some proofs now. So, let's take a look at this example here. We'll just read through what they have. So it says angle ABC and CBD are complementary. So if I look at this, I might mark ABC and CBD. These two are complementary. They add up to be 90 degrees. Then it says DBE and CBD. So DBE here and CBD, these two are complementary. So these angles are complementary. So how can I prove that angle ABC, which is right here, how can I prove that angle ABC and DBE are congruent? How can I prove that these two are the same? So this looks like there's a theorem that describes it. Let's talk about what that would be. So we're proving this theorem now, basically. And so when you're proving a theorem that's already been stated, like this would be what we call the congruent complements theorem. When we're trying to prove that, we can't just say because of the congruence complement theorem. We've got to use reasoning and definitions. So when we read this, we're writing out the given, and it would make more sense if we switch these two steps. And so we can conclude because they are complementary to the same angle, then they should be congruent. So I'm going to say angles DBE and CBD are complementary. So DBE and CBD, and that is because the angles complementary to the same angle are congruent. So that's basically like what I've just said up here, the supplements angles theorem, right? Or congruent supplements theorem. And then finally, because I know that they are complementary to the same thing, I'm going to conclude that ABC and DBE are congruent because of the complement theorem. So I had to describe what the complement theorem was first, and then I used it, okay? Let's take a look at this one here. We've got partial parts of the proof that's filled out for us, so we're just really going to either give the reason or give the statement. So step one, actually, let's take a look at what's given to us first. So given A, B, and BC are perpendicular, and angle 1 and angle 3 are complementary. So angle 1 and angle 3, they add up to be 90 degrees. Now, when you see the word complementary, a conclusion you can make is that they add up to be 90 degrees. And this will be used in your proof. So even though mentally you're aware of this, you can state that in your proof and reason it because of the definition of complementary angles or something like that, right? So let's write out our given. So angle, let's see, AB is perpendicular BC. That's part of our given. So our reason is given. And then it says definition of perpendicular angles. So if I'm describing something to be perpendicular, then can't I conclude that it's also a right angle? So I would say maybe that because these two lines are perpendicular, the angle that they form is 90 degrees, or it is a right angle. So I would say angle ABC is a right angle. And then step C here, it says the measure of ABC equals 90 degrees, and then it's the definition of right angle. So we've actually given it a measurement because we know that right angles equal 90 degrees. Now let's take a look at this. ABC equals measure 1 plus measure 2, measure of angle 1 plus measure of angle 2. So remember when we talked about anytime you have two angles that add up to be the bigger angle, that means that we're adding two angles up to equal the whole. That's called the angles addition postulate. So the reason we can conclude that these angle 1 plus angle 2 is the bigger angle that is created is the angle addition postulate. Okay, now we're subbing in because I know, look at step C here. I'm using the information, the statements written before to conclude new ones. So measure of ABC equals 90 degrees, and I have angle 1 plus angle 2 equals ABC. Well, I'm going to replace ABC with 90 degrees and then rewrite a new statement that says 90 degrees equals measure of angle 1 plus measure of angle 2. I basically just combined step C and step D together to create step E. Now, because I know that they add up to be 90 degrees, that would be, I could now describe them as complementary angles. So if I say angle 1 and angle 2 are complementary, well, I know that because of the definition of complementary angles. Okay. Then it has another given. Remember, we didn't state all our givens here, so I'm going to rewrite that. Angle 1 and angle 3 are complementary. Okay, something interesting is going on. If I have angle 1 and 2 as complementary, and then 2 and 3 are complementary, step F and step G basically describe to me the theorem that was said up here, right? The congruent complement theorem. So instead of saying the congruence complement theorem, I'm going to describe it. And then basically what I've done here is I've proven how the congruence complement theorem works. But I would say same angles. Let's see, angles complementary to the same angle angles complementary to the same angle are congruent. That's what the complements, or that's what the congruent supplements theorem says, basically. So because 1 and 3 are complementary, and then 2 and 3 are complementary, they're both complementary to angle 3. So I can conclude that, angle 1, let's see, angle 1 and 2 are complementary, and 1 and 3 are complementary. So I can conclude 2 and 3 are also complementary, or they're congruent. Okay, let's take a look at our final proof here. So in our final proof, let's see, number 2 here, let's read what the given is. Angle 1 and 2 form a linear pair. So when you see that two angles form a linear pair, in your head, you probably are thinking they add up to be 180 degrees, right? They're supplementary angles. And then it says 1 and 3, angles 1 and 3 add up to be 180 degrees. When you see that two angles add up to be 180 degrees in your head, you might also be thinking they're supplementary angles. And then we're trying to prove that 2 is congruent to 3. Angle 2 is congruent to angle 3. So let's read the information given to us that's partially filled out. So the given is everything that's stated in our given is written down in our given. So what can we conclude from this information? Well, couldn't I say that angle 1 and angle 2 are supplementary? Or angle 1 is supplementary? My writing is not very good, but I would say angle 1 is supplementary to angle 2. Because the supplement theorem tells me that if two angles form a linear pair, then they are supplementary or they have to be 180 degrees. And then it's saying angle 1 is supplementary to angle 3. So that's going off of this given right here. And that's, I think, also the supplement theorem, right? Okay, then because these two angles, angle 2 and angle 3, are supplementary to the same angle, see how they're both supplementary to angle 1, I can conclude that angle 2 is congruent to angle 3. And we have just proven the congruent supplement theorem by saying angles supplementary to the same angle are congruent. So that was very similar to this proof here, but it looks like because some more information, some more straightforward information was given to us, it didn't take us as long to finish. All right, that's all I have for you guys. I know those last two proofs maybe mess with your head a little bit. Don't worry too much about it. Just be familiar with what these terms mean and what they say, so that if I give you information, I say, tell me why this is true. You can support it with the right reason, okay? We will go over some stuff the next class just to review. And if you want to come prepared with questions for your review, please do so we can talk about it.